everybody, and welcome to this video. In this video, we're going to have a look at the GDE Prelim 2020 paper question 9. Question 9 is on calculus, so let us have a look at the questions. Please make sure you review the section before attempting this question and make sure you've answered it before watching the video. So let us start with 9.1. This is determine the points on the curve of y is equal to 4 over x, where the gradient of the curve is where the gradient of the tangent of the curve. So we have that the gradient of the tangent is -1. So we want to get the points on the curve where you have the gradient being equal to -1. So the first thing is the gradient of the tangent would be equal to the derivative evaluated at that point. So we want dy by dx. The first thing is to find dy by dx. So this here I can write as 4 times x to the power of -1. And when I use my rules, I get 4 x to the power of -2. So what I would like to do to find the gradient, we know that the derivative is equal to the gradient evaluated at that point. So we're going to equate this to -1, the gradient. So we're going to equate the derivative, which is the derivative at any point, to the gradient of the tangent at -1, and then we're going to solve for x. So dividing both sides by 4 minus 4, you get that x is equal to 1/4. Flipping both sides over, you get x is equal to 4x squared. So x is equal to plus or minus 2. So that is the x coordinate. So there's 2 points where then the gradient of the tangent is equal to -1, and the x coordinates are 2 and -2. So how do we get the y coordinates if we know the x coordinates are true? We substitute it in. So for x is equal to 2, y is equal to 4 over 2, which is 2. So the one coordinate is 2 and 2. For x is equal to -2, the corresponding y coordinate, when we substitute the x, is 4 divided by -2, which is -2. So then this coordinate is -2 and -2. So these are the points on the curve where the gradient is equal to -1, which is the same gradient as the tangent. Okay, let us have a look at the next question. So it says you have a cubic function with the equation y is equal to x cubed plus ax squared plus bx plus c, and it's drawn below. So we have f of 1 is equal to f of 4, which is equal to 0. So that's giving us our x-intercepts. So it's saying that we have x-intercepts at 1 and 4. And if you look at the graph, that's exactly what you can see. At 1 and at 4, we have our x-intercepts. It says f has a local maximum at b and the x-coordinate is 4. A local maximum at b and a local minimum when the x-coordinate is equal to 4. So this one here we know is our maximum, our one turning point, and there is our minimum, our turning point. So it says, show that A is equal to -9, B is equal to 24, and C is equal to -16. Okay, so what we have over here are the x-intercepts. So we can write, so we can use the x-intercept form of this. So y is equal to A, x minus x1, x minus x2, x minus x3. So that's putting in our x-intercepts for each one of them. We know our a value is 1 because we can see the coefficient of a of x cubed is 1. Our one x-intercept is 1, so we put x minus 1. And where this 4 is, we know that it's going to be x minus 4 twice. Okay, because it touches it once and it goes down in once. So that's putting in our x-intercepts. So this x minus 4 is repeated because it's a turning point. So then all we're going to do is multiply out. So this here is x minus 1 times x squared minus 8x plus 16. Please remember to FOIL that. Okay. and then we're going to distribute the x. So we're going to x cubed minus 8x squared plus 16x, and then we're going to distribute the 1. So minus x squared plus 8x minus 16. Then we're going to group our like terms. We get x cubed minus x squared minus 8x squared is minus 9x squared. 16 minus 16 plus 8 is 24. So we get 24x, and then we have minus 16. And there we can then see that the a value, which is the coefficient of x squared, is 9. The b value, which is the coefficient of x, is 24, and our c value is minus 16. So we have done that. This becomes such an easy step if you use the correct formula. So once again, because you were given x-intercepts, you use the x-intercept form of the equation, and it becomes a simple task. Then it says calculate the coordinates of B. Now, let's say you did not get the first question. It does not stop you from moving on, because now you know what is the A and the B and the C. So if you did not get the first answer, you can still continue with the next one by using the information that they told you. So this is our equation. And how do we get the coordinates of B? Well, the coordinates of B is a turning point. So for a turning point, we take the derivative and we equate it to 0. So the derivative is 3x squared minus 18x plus 24 is equal to 0. I'm going to divide everything by 3, so you get x squared minus 3 times 6, yeah, sorry, plus 7 is equal to 0. Then our factors of 7 that give us minus 6. Do I have the correct signs? Yes. I feel like I've made a mistake. So 3x squared minus 18x plus 24. 24 divided by, is 8. Sorry. So 24 divided by 3 is 8. Anyway, so then we factorizing the factors of 8. So it's x minus 4 times x minus 2 that give us 6. So here we get that x is equal to 2 or x is equal to 4. Now we know that x is equal to 4 is that minimum. So for B, we know the x coordinate is 2. So for B, x is equal to 2. And how do we get the y coordinate? Well, we substitute it back into the original one. So 2 cubed minus 9 times 2 squared plus 24 times 2 minus 16. Okay, so let's type that into our calculator. 2 cubed minus 9 times 2 squared plus 24 times 2 minus 16. So we get 4. So that means B's coordinates are 2 and 4. Okay. So it says determine the values for which k has only negative roots. So we want to know when will it cut the x-axis on the negative side. Now on this graph you can't really see, but on this graph the y-intercept is minus 16. So we can view this as f of x minus k being how many times should we shift it up or down so that the y-intercept moves to the positive side, because then once that happens, then it will cut on the negative side. So if we move the 16 units up, our y-intercept is then there, 0. And then if you shift it any more up, you're going to get a negative x-intercept. So you want to shift, so your k should be equal to, okay, so you want to shift it 16 units up, so you want f of x plus 16, so your k should be equal to minus 16. So k is equal to minus 16, because minus minus gives you a plus, because we want to shift it 16 units up, So K should, so when you shift it 16 units up, so K should be less than minus 16. So if you shift it any more than 16 units up, then what will happen? It will have an x-intercept that is negative. These x-intercepts get shifted up, so they don't intersect there anymore. So the only one would be on the negative side. So that is what happens when, and just be careful because we took the K over to the other side, that's minus K, but we want to, if you have anything bigger than positive 16, it will have, which is the same as shifting 16 units up, it will have negative roots. So we're going to say K is less than minus 16 because remember you're going to have minus K. So it's going to be then that positive that we're looking for. Okay, for the last one, we want to determine the values for which it's concave up. So for concave up, we're looking at when is the second derivative positive. So the second derivative is the derivative of the first derivative. So we get 6x minus 18 is greater than 0, which means 6x is greater than 18, which means that x is greater than 3. So that is the values for which x is concave up. I hope that you've understood all of this. And if you haven't, please review your section on calculus before continuing the rest. Thank you for watching. Bye.